Thank you for coming to this fireside chat. I'm going to be speaking with Asif Khan, whom I have known for about 4 or 5 years now. Asif is a co-organizer with my AWS meetup in the Bay Area, as well as he and I co-authored the Pragmatical AI book, which has been published recently this month. Um, but I would like to have Asif introduce himself. Asif, go ahead and tell us who you are and all that jazz.
Yeah, John, always nice to talk to you. This time over video. But yeah, so who am I? Hi, everybody. My name is Asif. I've been around the industry for 17, 18 years now. And most recently, like right now, I'm managing director, head of data engineering at CPP Investments. CPP, for those who don't know, we try to increase the return rates of the pension funds in Canada. And prior to this, I was at Amazon for 5 years. And I basically was involved in the ECS story, AWS Fargate story, ran the business side of that. And before I left Amazon, I was running Alexa AI customer experience, dealing with data and scaling data issues and ensuring that the platform is ready to be consumed by users of the platform. So that's me.
Okay, that's a good setup into what we're going to talk about. We're going to talk about trends in AI and data. So, Asif, in summary, can you tell us what is the role of data and AI these days?
Yeah, that's a pretty interesting question, John. Primarily around because the buzz is around data and AI. Everybody wants to be a data-driven company, and that's absolutely the right thing to do. You need to let the data let you decide what you want to, what your decisions should be. And when you look at even today in the pandemic world, there are startups which were able to predict the movement of the pandemic across the globe by looking up or doing OCR on local papers in China. And then they correlated that with travel patterns of people flying around the world. And they came within an order of magnitude of precision of, of telling people how this will spread. And now post uh, pandemic, or kind of in the pandemic, we are realizing how true that was. So that as an example, as a launch pad, gives you a very humbling feeling that we as humans, we only know so much. And our cognitive capacity can process so much. There is some study which says a human can process 7 things at the same time from the frontal cortex or something. Now, when I look at data, the vast amount of data that one human, let's say John or Asif, accumulates over his lifetime helps us make decisions, better decisions as we see more data and we apply them, make mistakes, learn from it, and move on. Imagine if the whole humanity's data was used to make collective decision. That's the whole concept about governments, that's the whole concept about groups, that's the whole concept about how companies are run, how economies are run. But when you abstract it back to how do businesses use data, and that was the premise of the book, John, like we worked on. The premise of the book is really how do you apply all this data and derive intelligence from it through use cases. I'll give you a very simple example, which is very close to my heart, and is bias. And bias is a big topic in AI today. Models are doing things that people do not understand, and as models are a reflection of humans who built them, because we are humans writing algorithms. So bias, generally speaking, is a very broad term, but it becomes very dangerous when applied to specific instances. For example, when somebody applies for a loan to buy a home and the underwriting model has bias, and they look at your race or your demographic or your income, that becomes tricky. It gets to a next level problem where even looking up somebody's zip code can be used to derive things like who you are, and how much of this is ethical, how much the model should do is very, very important. And as you look at data around us, we are living in a sea of data. It's an ocean of data around us. We are in the information age. But when you dial back and look at this ocean of data we have, we need to be very careful how we use data, how we bring all this data into the correct place with correct entitlements, that the right people can see the right amount of data, but also loosely link it so that we can correlate for the correct purposes. And I think when you look at that data platform, that is key and essential to, and there could be structured data, unstructured data, transactional data, like you name it, right? Social data. But how do you use this data to make decisions and drive returns for your business, for your stakeholders, for your users, for your customers? Is, I think that's the key part where the data story is moving. We all know data-driven decision making is the right way to go. But as we move to or shift right on this one, what's happening is data, understanding data and keeping data in a format that could be loosely used. A distributed ecosystem of data can contribute to your decision making is where we are moving on, to be honest.
So I keep hearing terms like deep learning and machine learning. How are they related to data and or AI, for example?
That's a great question. I've struggled with that personally because you hear these, and some people will throw more terms at you with transfer learning and reinforcement learning for a simple user, simple-minded country boy like me. That's I would rather have a simple conversation. So I would say the simple conversation is like when you talk about data is the underlying foundation, but when you say ML, machine learning is really the algorithms, the statistic that has been there for ages. Like all of us have done regression algorithms in class. Some of us have done operation research. Some of us have done probably logistic regressions and things like that. This is not new. If you look at regression, they are used in business today for identifying the sample distribution. Uh, Statistics is used to predict elections today
Yeah.
because they take a small sample size and extrapolate the result size. Now, when you look at that, statistics is based on data. There are algorithms on top of algorithms, and honestly, some of the algorithms that were invented decades ago are being reinvented or reapplied to get results. So that's machine learning for me. The machine trying to do the statistics that humans were doing in the past.
Okay.
Deep learning is the next evolution of that. Deep learning mimics how our brains are wired in terms of neurons, layers of neurons. So with an input, a certain layer understands it certain way, transforms it, and passes it back to the next layer, and then with each layer there's more learning, and there's probably some memory also in it, uh, and then the output is a complex uh, understanding of the problem space. And you can now use a lot of data to train your model. I'll give you a very simple example of deep learning using a human example. When you walk with your children, like when your kids are small, a 3-year-old, and you tell them it's a car, and he'll say, why? And you don't tell him why. He'll think it's the next time you go and show them the red truck, and they will say, it's a car. Then you say, no, 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 it's not a car. A car is 4 wheels, which is more, the height is lower. Now that's got features that they remember, and they move on. And then you say, then that's a truck. They remember. The next time you show them a trailer truck, and then they say it's a truck. And then next time you come back and show them a green car. And through this neuron or mechanisms of distributed learning or connecting different neurons, a child learns what is a car, what is a truck, what is a trailer.
Mm-hmm.
That is deep learning in essence.
Okay.
With cloud technology taking over, deep learning was very expensive till very recently. And with the cloud taking over and commoditizing a lot of IT and making GPUs available. For example, deep learning is available to everybody now, and you can use it to harness the power of these complex algorithms, if you may. Finally, we come to AI. So AI is the Uber term, right, which encompasses machine learning today, which encompasses deep learning today. Yeah. So we could say this printer sitting next to me has AI. What does it mean? It means it has the functionality to use the data and make decisions. You're not talking, it could be statistical algorithms, it could be deep learning algorithms, it could be simple factor math, A over B. AI is really a use case driven conversation where we say, and that's what we talk about in the book, that when you look at healthcare, for example, a radiologist can use AI, which is the application of deep learning or machine learning.
Yeah.
Now, how it's implemented is where computer programmers like you and me come in, scientists come in, where we talk about how do you implement these algorithms, how do you make them efficient, how do you use AWS, for example, and so on and so forth. So that's my mental map of the difference between ML, deep learning, and AI.
Okay, so you mentioned the cloud in between. How can AWS help us manage all this machine learning, deep learning, AI, and also deal with it in other ways? What are the services that AWS provides, or what's the best way to make use of the cloud?
Yeah, first of all, it feels good to be in this side of the community because now I can make asks. So the key part about, I think AWS has some great services like SageMaker, the NLP story is great. Alexa has some great technology pieces under the hood. With AWS Nitro, the performance is getting better for a lot of these EC2 systems. And with more and more, right, like container, for example, was a huge thing which simplified how you deploy AI, how do you make it reusable, packageable, deployable. I think one thing, AWS is a Lego box. You know, we have many different types of Legos. I put it together, and I can make it. If there's one wish I have, which I can make on behalf of the community, is more managed services, more functionally managed services. Like, for example, what Google does with Doc AI, which is nothing but a DocuSign, which is using AI to underwrite or sign. Look at those use cases functionally, industry-wise, and figure out how to enable them through the Lego blocks that actually exist. How do you speed up deployment of AI through those use cases in places or in companies where, for example, you don't find an AWS or a Google engineer, right? So the talent curve is skewed. The question is really around how do you help businesses adopt AI not through Lego blocks, but higher level functions that could be used, for example, GPT-3. A lot of app developers will start using GPT-3 because it's so easy to use and gives you answers whatever you ask. That's a higher level function that could be used. And to be honest, to be fair to AWS, we have seen AWS do that with AWS recognition, then Poly, and Lex. So there is precedence here. But as we go industry by industry, there is a great opportunity for AWS to try to help and move the needle on AI if we can look past the Lego blocks to higher order functions.
I see. So, what can you give us some examples of how a company could use the services that AWS now provides, even if they're not managed services? I know some of them are managed. Well, what are the other non-managed services, and how can they be used?
Absolutely. So I think for people, like we are doing that now, to be honest, at CPP, that's my job. We are looking at data engineering and seeing how we can apply novel techniques for improving the rate of returns for our stakeholders. But when you look at SageMaker, it's a notebook that anybody can go and experiment with. Anybody can do, like, you can load an NLP notebook from GitHub and play with it and learn. It enables learning, it enables research, it enables experimentation, which is great. If you look at AWS recognition, if you look at AWS Polylex, these are simple APIs that you can use and incorporate in your apps, because the life and blood of businesses is the apps. And as you help embed more AI in the apps, the more relevant it becomes for the business. So when you think of this, like, yes, I can run a big model on EC2. EMR is great because we can run distributed computing cluster problems on that. When I have tons of data and I want to convert data, wrangle data, and get it to a place that is consumable, EMR is a great place. Athena is awesome because Athena, with Athena, you can just query your data in Parquet and be done, and it's super fast, super efficient. So there are tons of these tools in AWS basket that people can use. And you need to know it, right? So today, and you have to be use case specific and driven. Like, for example, you don't want to put a jackhammer on a needle or a nail and break it, because it will break. So I'll give you an example. You don't want to run a large EMR cluster on something that can, that doesn't need so much horsepower. But what are the other ways you can do about it? Like AWS Batch is great for running jobs. Fargate is another big thing. Even on the code side, which you and me have talked about, on the code side, the integrated environment with code build, code deploy, code commit is great, because now I don't have to manage, code in GitHub and with all these distributed things, and invest in multiple places, and I can focus on delivering business returns. You can be all in on AWS, or you can have a DR strategy. But I would say those are some of the things, some of the tools that come to my mind off the bat if I was starting on AI and data to get going. But things like lake formation is great to start, where you can just spin up a data lake and go for it. Redshift, the whole database story is great. So I would say those are things that are just bread and butter at this point of time. But if you're starting with your data story, you probably are looking at a big data situation and trying to figure out how to use it, all the open source pieces that you have, and EMR provides all of that. And if you're on the AI side, you're trying to start experimentation, and your hook or entry point is SageMaker or one of these APIs for text to speech or optical image recognition or something like that. But that's how I would start about it if I was new to AWS.
What are some of the challenges you see specifically? If I had a database with data, I would have to secure it from unauthorized access and all that. But for AI, we use such large quantities of data, and there's all these hackers trying to take sensitive data out of companies. And when you do get hacked, it's terabytes of data with because once you get in, you have access to everything. There's so much data. How do we keep it secure? How do we organize the sensitive data in there? What challenges do we face? Not just in security, if any other challenges you can talk about, even storage and retrieval and all that.
Yeah, I think that's a very good question, and it's an intriguing question. It's the kind of the times we live in, right? Where data. I was just listening to somebody where they said data is the new oil. Whoever has the most data controls the world economy in a way.
Exactly.
So you see that happening, and it's a tremendous challenge for businesses to keep it secure. But I am a true believer in cloud, and if you follow the best practices in cloud, right, for security, resiliency, operational excellence, cost effectiveness, these problems are already addressed, to be honest. For example, if you have S3 bucket where you're storing stuff, you can lock it down. You can use service roles. You can provide read access only. You can prefix them. There's many different ways to do that. You can even put data entitlements on top of it, so you can have fine grained access or coarse grained access. The coarse grain could be at the bucket level. IAM roles could be applied, but fine grained, you might go and look at something like Apache Ranger and say this column should be used by John, that column should be used by Asif. But when you look at just the concept around security, Uh, it's a shared responsibility model. I understand that. And like any utility company out there, they promise the pipes, the network that AWS provides, the storage they provide, but it's also your responsibility. What apps are you consuming, the data, how you have configured your VPC, how are you allowing access to your resources? Are they through service roles, or are you like storing keys on GitHub, things like that. So those are amateur mistakes that everyone should avoid. But AWS does provide a lot of functionality. I think they have a bunch of IAM diagnostic tools, like slipping my mind, but there is a couple of diagnostic tools that you can deploy to figure out what's wrong. Like, for example, I love VPC flow logs because it just, the network traffic is captured and I can know at real time. And if I put a Kibana dashboard on top of it, I can build a control and command center very quickly of what's happening with my network access and data access. Yeah. So, but also, I think you should also think about DR, where you are storing data, and be very careful about all the laws that are getting passed around us with CCPA in California, GDPR in the UK, in Europe. Yeah. But the key part is going to be, you have to look at data residency, you have to look at data lineage, and again at provenance, right? Where did it originate? Who had access? What was the data journey from origin to consumption? And then when you look at that, you need to be able to authenticate, authorize, you need to be able to prove to regulations or to your users, to be honest, that if there's an app that is using my data and there's a New York Times article about that app, I probably am going to drop them. So you have, as an app builder, you have the responsibility to prove the data origination, lineage, provenance, and then residency requirements for all of this. So I would say it is everybody's responsibility to keep data secure and make sure that we use it for the right purpose. But at the same time, I think cloud gives you the tools already. There's a bunch of tools already out there. I think S3 Macy is a great product because it gives you diagnostics, and you can build analytics on top of it. But I would say if there is one thing on the data side we are looking at, since data is such a valuable commodity right now, we'll only see more people trying to access it, more people trying to use and misuse it. So we have to be vigilant as implementers, as practitioners, to evolve our security posture to make sure that based on the data profile and the data classification, it's only available to the people that should have it, put guardrails around it, and make sure that, we protect data really as an enterprise asset versus not.
Yeah. So when we started off, you had mentioned that bias is one of the challenges for the data. But the fact is, the more data we collect, the more bias we're going to collect with it. You're not going to be able to remove it. Or are you going to be able to? Do you have any ideas? Do you have any examples from maybe from Alexa that you used it? Hold on one second, Alexa.
I love it when she does that. But I think that's a fair question, right, John? But I go back to intelligence, and I go back to the human example. We receive a barrage of information today, and the best decision makers read a lot.
But the best decision makers?
They read a lot. They read a lot of books, and they read a lot of varied information. Why? Because a lot of different perspectives help you make decisions. And think of perspectives as algorithms. Correct. When you run many different algorithms, your decisions will be better. And that's what reading does to us. It fine-tunes our thought process and our frontal cortex. And I would say, as we see the data explosion happening around us, like we have a sea of data that we're consuming, it's also propelling a bunch of algorithms in the frontal cortex here, with new algorithms coming out every day, which just see more data, which are less biased. There's a whole novel research going around bias right now. A lot of very smart people are working on reducing bias in models and algorithms. We are not there yet, but one way to counter bias is explanations. Like when your kid says, "I don't want to eat that green vegetable," there's bias. He heard it something somewhere. He's not been able to correlate it. So then you go back and explain it that, hey, green is good for you because it does this for you, versus that information that you got is probably not explained well or not founded in robust theory. So when you look at trust, and there's a great talk by the Harvard professor, I forget her name. Trust is built on three pillars. This is authenticity, the rigor of your logic, and empathy. And that's how we grow up our kids. And that's the love I have for algorithms and data. That's how you need to nurture these. And it's what a lot of scientists are doing around us, where they're basically saying, let's build authentic algorithms. Let's have a rigor of logic in these algorithms. And let's have this empathy piece of this, that we are not looking at like data we should not look at. The rigor is that, right? And I'm an optimist. I'm very hopeful that we will have algorithms which are less biased than more biased. There will always be misuse, like with every technology, like cryptography, to be honest. I studied cryptography in school. So but at the same time, to your question, how do we get there, is going to be through novel experimentation, in whole areas, in explainable AI, in interpretable AI, in unbiasing systems. So I think it's a work in progress, but I'm very hopeful that we'll get there.
Well, we're coming close to the conclusion. Let me ask you, the last few years, I've seen a tremendous explosion in data science and data engineering. And I know, I think 4 or 5 years ago when I first met you, you were not doing AI or data science, but now you're a general manager of the data division at some place. How easy or difficult is it for someone to transition, someone who doesn't have any experience with data or AI, to get into the field, especially if they can leverage AWS and the cloud? What tips and tricks do you have for them?
Yeah, my advice would be curious. I've been curious all my life, and all my friends are like, John, we wrote the book because we were curious about figuring this out. The more you push yourself to learn, the more you learn. Like the cloud computing technology, AWS, is a Swiss knife in your hand. You can use it 10 different ways. And again, I wouldn't say you have to, probably for doing novel research in data science, you probably need a PhD. But if you're inventing algorithms and having lived in Alexa and other places, it starts with the business use case, with the apps you build that you serve your customers. So you know the business, you know the data already. You have worked with data already. If you have built an app, you are a data engineer. You understand data. Data engineer has two parts, data and engineering. And I say this all the time. You need to know data before you can be an engineer in data engineering.
Okay.
In my mind, everybody who's in tech, everybody who's developed an app is a data engineer from that perspective. Okay. Yes, there are new technologies that came up like big data, Parquet and Hadoop and other places that you might have to learn, and not trivializing people with that skill, but they've picked up the skill and they have become really deep experts in tuning systems and moving on from there. And I would say be curious, pick up a blog, pick up a book, pick up a notebook, run it. And maybe it leads you to do your PhD. Maybe it leads you to build a startup of your own. Maybe it leads you to learning more and sharing your knowledge with others, right? All are good outcomes. So I would say use AWS and cloud as a Swiss knife, and use the curiosity within you. And I honestly think everybody has that curiosity as your weapon, as your really sharp knife to go after novel problems and use AI and data for it. Like, and of course, GitHub. You go search for anything in GitHub, you'll find a project. All you have to have is the desire to learn it. So that's how I grew up into this role. And I hope everybody grows up into amazing roles as they move on. But yeah, I would say my only secret to my success is I've been a lifelong learner and student. And you can learn things from your 5-year-old, and that's that. If you keep that attitude or keep that within you, this sky is the limit.